Let's create this rolling text effect in geometry nodes. We're going to create subgroups, and the techniques learned will be really useful for various applications. So with that, let's actually begin the tutorial. In our default scene, we'll bring our cursor to the junction of these two windows, click and drag to create a new window, and change this from the 3D viewport to the geometry node editor. Then we'll press this plus button to create a new geometry node tree, and we'll zoom in and start creating the nodes. We can select the group input and tap X to delete it, and then the first thing that we need is a line that's going to change based on the number of letters present in our word. So I'll press Shift A and search for a curve line, and I'll plug the curve into the group output. Right now it's going up on the z-axis by 1 meters, but we want it to go along the x-axis. So we're going to change this from points to direction, and we're going to have the direction not on the z, but we're going to have it on the x. So we're going to change the z to 0 and have an x of 1. Now by changing the length, we can change the length of this line. So we're going to currently keep the length at 1, and we're going to use a value node which is going to control the number of letters in our word as well as the length of the line. So let's say this value is 5. The length should be 5 meters or something like that. Now I don't want this value to be a floating number, so instead of value I'm going to search for an integer, and this way we can have only round numbers, which is necessary because the number of letters in a word is always going to be a whole number. Let's plug this into the length, and maybe I don't want each letter to be present 1 meter apart. I want it to be maybe 0.8 meters apart or something like that. So I can press Shift A and search for a math node and then plug the math after the integer node. Now instead of add, I'm going to switch this to multiply, and I'm going to multiply it by a value of 0.8. So now based on the number of letters, I can multiply it by 0.8 and use that as the length of the curved line. Now the curved line has only 2 points, but we need the same number of points as the number of letters there are in the word. So I'll press Shift A and search for a resample curve node, and I'll plug that in right after the curved line. For the count, I'm going to simply take this same integer and plug it in. So that way, if there are 3 letters, there will be 3 points created, and if there are maybe 6 letters, there will be 6 points created, and along with that, the line also changes its length accordingly. Now on each of the points that we created, we need to actually instance a circle on whose points will instance the letters. So I'll press Shift A and search for an instance on points node and plug that in after the resample curve, and for the instance I'll use a curved circle. Now I'll plug the curved circle into the instance, and you can see how the rotation is. We obviously don't want the rotation like this, we want it to be on the y-axis, so we'll rotate it about the y-axis by 90 degrees, and this is the exact rotation that we want. Now we don't need this much of a resolution for each of these, so we'll actually reduce this down to something like 5 so that we can actually see the rotation. We want to rotate each of these about the x-axis, so we'll press Shift A and search for a rotate instances node and plug that in after the instance on points. Now you can see that by rotating it about the x-axis, we're not getting the exact rotation that we want. So instead of using the local space, we'll use the global space by unchecking that local space, and now rotating it about the x is giving us the exact rotation. The reason why we're keeping the resolution low is so that we can see the rotation nicely. If we have a really high resolution, we can't actually see the rotation at all because it's a circle. So we'll increase this resolution later on and choose the number of points after this rotate instances node, but just to help visualize the rotation, we'll keep this fairly low. Now clearly you see we want to rotate the x-axis value, but I don't want all of them to rotate in the same direction. I want every alternate one to rotate in the opposite direction. So what I'll do is I'll press Shift A and search for a combine XYZ node, and then I'll plug this into the rotation socket. This way we can control just the x-axis value using a socket over here. So I'll press Shift A and search for a value node, and I'll use this value as the x-axis value for the combine XYZ. Now I can just rotate this and it rotates properly, but all of them are rotating in the same direction. So remember, we are actually rotating these instances which are coming out of this instance on points. So every instance has an index that is a round number like 2, 3, 4 and so on and so forth. So we can access that index using the index node. Now every alternate index we can multiply by -1 so that the rotation happens in the opposite direction. So to find out every alternate index, we can search for a modulo node, which is a math node with the type set from add to modulo. Now we can plug this index value into the first socket, and the second socket we can change to a value of 2. So modulo returns the remainder after division, so the index is going to be divided by 2 and the output is going to either be 0 or 1. Since we want this to be multiplied by -1 or +1, what we can do is we can search for a map range node, and we can change the toMin to -1. That way, if this output is a 0, it'll become -1, and if it's a 1, it'll remain as 1 itself. So let's plug this value into the value, and now this result we have to multiply with this particular value that we have. So I'll press Shift A and search for a math node. I'll plug it in after the value, and we'll take this result and plug it in, and we'll change this from add to multiply. So that way, if you actually rotate this, you can see how they're rotating in opposite directions. We have the first one rotating in the counterclockwise direction, and the second one is rotating in the clockwise direction, and the third one is anti-clockwise again. So if we look at at that, it looks perfectly alright. So this is the rotation that we're going to be using. We will later on animate this value to create the animation by adding keyframes over here. Remember, since this is now taking in radians, we can start off with the value of 0 and end with the value of any even multiple of pi, such as 2 star pi, to create one full rotation, and it'll look the exact same. So we'll do that in the animation section. So now that we have that created, we want access over every individual point there is. Remember again, these are currently instances, and instances acts as a singular object, and we can't access the individual points. So we'll press Shift A and search for a realize instances node so that we get access over the individual points present in the entire object. Now we'll press Shift A and search for a curve to points node so that this curve becomes points, and we can change the count over here. Since we want this to be more or less circular, we're going to go ahead and increase this resolution up to something that'll be good enough. So I'll go with 64, and now it'll be perfect circles. This count we can use another value node to control so that it becomes easy to change later on. And even this has to be a whole number, so we're going to use an integer. Now we can plug this into the count, and this will determine the number of letters present on each of the circles. Now on every single one of these points, we want to instance the actual letters. So we're going to shift this to the side, and we're going to go ahead and search for an instance on points node. Now for the instance, we're going to have to use a string to curves node, and we can type in whatever string we want over here. But to make it easier, we're going to use a string node, and we're going to plug this in for the time being, because we will be taking all of these nodes that we are about to create and converting them into a singular node group so that it becomes really easy to make this modular and change the letters and things like that. So now let's take this curve instance and plug it into the instance, and for the string let's type the letter n. So now you can see on every single one of the points we get the letter n, but the rotation isn't right. So we can take the rotation from here and plug it into the rotation, and that way we get the right rotation. But now if we were to play around with this value, you can see that there's a certain point where this rotation just flips and everything becomes upside down, and that's definitely not desirable. I'm not completely sure as to why this flipping is happening, but I definitely do not want it, and that's why I'm not going to actually use this rotation socket from here. Instead, we're going to actually orient the rotation according to the actual position of each of these points, and we'll use that to orient each of the letters. So I'll press Shift A and search for a capture attribute node, and I'll plug that in just after the realize instances node over here, and we want to capture the position of every single one of these points. So I'll press Shift A and search for a position node and plug this into the value, but remember position is a vector, so I'm going to change this from float to vector and then plug position into the value. Now we have the position of every single one of the points. Now I can do some math on those positions so that I get a vector that's just giving me the correct orientation. The first thing is I do not need to worry about the x-axis location of the position. I only want the y and z-axis values. So I'll press Shift A and search for a vector math node, and I'll plug this attribute into the first socket, and I'll change this from add to multiply. Now I'll multiply it by 0 on the x-axis and 1 on the y and z-axis. Now I need to align the Euler to this vector, so I'll press Shift A and search for an align Euler to vector node, and I'll use this vector as the vector, and I'll take this rotation and plug it into the rotation. Now obviously this is not the correct axis, so I'm going to have to change the axis to y, and that way I get the correct rotation. Now if I was to go ahead and change this value over here, you can see that there is no unwanted flipping and it's rotating exactly as expected. So now that we have that, the next thing that we have to do is make sure that this M is occurring only for the first letter, which means it should happen only for these points over here. For that, we can use this selection node and actually select the correct indices. Because we've actually realized instances, every point now has its own index. And remember, the number of points that we're creating for each circle, which is each letter, is equal to this number over here. So what we can do is we can compare if the indices is greater than or lesser than a certain value, only then should it get n. So I'll press Shift A and search for an index node, and I'll search for a few compare nodes. So I'll press Shift A and search for a compare node, and now remember, I want to compare if this index is greater than 0 and less than this number, then it should get m. So I'm going to say, is the index value greater than 0? So the index goes into socket A, and we keep b as 0, and we also have to check if the index is less than this number. So to check both these conditions, I have to press Shift A and search for Boolean math node, and then I can plug this into the second socket, and I need to compare this with the first socket. So I'll duplicate this greater than node, and then I'll change this from greater than to less than, and I'll plug this into socket B, and I'll take this index and plug it into socket A. So now we're checking if the index is greater than 0, and we want to check if the index is less than this particular number. Only then should it be selected. So now you can see we're missing one m, so that's because the indices start from 0. So instead of greater than, we're going to change this from greater greater than or equal. So that way we get all of these M's and it works perfect. Now let's go ahead and create all of these nodes into a single sub node so that we can simply connect these up and we don't have to repeat the process multiple times. So let's just connect these and these. So shift select all of these and then press Control G to create a subgroup. Now if we press this back arrow to go up, we can see what subgroup we have. Now the entire idea is that when we actually duplicate this node, we should be able to plug this in right afterwards and change the letter accordingly and make a few connections so that we get it for the next point present. So that isn't exactly what's going to happen now. As you can see, just connecting this in completely ruins the setup. So let's delete this for now, connect this back up and go into this node group by pressing this button over here and start messing around with the things inside. So the first thing is this socket B that we're taking from the outside. It is the value that we're making sure it's less than. So in here, you can see all the inputs and outputs. Since B is the value that's less than, we're going to rename this from B to less than. And we also want this not to be a float, but to be an integer. So let's change this from float to integer. And we also don't need it to be on top. We're going to shift it down. So we'll press this down arrow to just bring this down so that it is the third socket. Next up, the points that we're going in over here have to be the same points that go out for the next set of letters. So we're going to take this points and plug that into the group output as well by just dragging it into the next socket over here. Now this greater than or equal to should also change according to which node we're using. So we're going to take this socket and plug it into an input and we're going to rename this to greater than. This also has to be an integer. So we're going to change the type from float to integer. Now since this less than and greater than is going to keep changing for every node, we want to provide these as outputs as well so that we can just connect them up to the next nodes. Now if we look at the logic, the integer that is currently the max value is going to become the min value for the next set of points that we use. So we can take this less than and plug it in directly to the group output and we'll go down over here and change this outputs from less than to less than underscore n for the next set. But again, remember the value that's less than right now is going to become the minimum value for the next one. So we have to check if that value is greater than. So we're actually going to rename this to greater than underscore n. And we also require a new value for the less than. So that's actually going to be the less than plus the number of points present in each of these circles. So I'll press Shift A and search for a math node and I want to add the number n to this less than value. So let's take the less than, plug it in, and let's take this and plug that in as another input, which is going to be n. So let's come up here, change this value to n, and we'll change the type from float to integer again. Now let's plug this into another output and we'll change this value over here to less than underscore n for less than next. Again, this has to be an integer, so we'll change this from float to integer. And we need to actually provide n as an input, which we can do from the outside. The last thing that we need is this string value should be available in the external node over here itself, that we can just type it in accordingly. So we're going to remove this string value and take this string and just plug it in right after the n, and that should be fine. However, there's still one issue that we need to address, which I'll show you from the outside, because right now we have a node group that's taking in the points, it's taking in the rotation, and this is the value n. So we can plug this in right here and we can give it whatever string we want and we get the correct output. However, again, if we press Shift D and bring this in here, we have to take the points and plug it into the points, but we're going to have to sit and use a join geometry to actually join the new instances in. Now, of course, we don't get anything because we have to choose the correct less than and greater than values. So let's take this greater than n and plug it into the greater than over here. Take the less than n and plug it into the less than. And now you can see that we have the correct letters present in the next socket. Let's change the string from m to something like o, but the rotation isn't there. So let's take this rotation and we can plug that in over here. But again, I don't want to keep taking things from the outside and plugging it in. So I'll go back into the node group and I'll take this rotation socket and also plug it as an output right here, so that over here I can just take this rotation and plug it into the rotation. Now remember, it's much easier if all of these are in this exact same order. So remember, greater than is on top, so we're going to change this greater than on top, and similarly rotation is the second input, so we'll bring this to the second input right after the points. Along with that, because this join geometry has to be present outside, I don't want that. I'm just going to plug that into the node group as well. Let's delete the join geometry from here, take the instances and plug it out. But now let's go into the node group and then press Shift A and search for a join geometry. And initially I'll take this join geometry and just plug that in as another input, and I'll come down here and I'll call it joined instance, and I'll bring it to the top so that it's the absolute first socket. And then I'll take this instance on points, plug it into the joined geometry and plug that out into the instance. Next, I needed to flip the greater than and less than. So let's go to the output over here, take the less than and just press this up arrow so that it gets flipped. Similarly, the rotation has to be right after the points. So let's shift that up, and now even that is fixed. If we go back out now, we can take this instances and plug it into the joined instances. And again, we're going to have to sit and fix this n value for every single one of these nodes. I want to just be able to connect it up. So within the node group, I'll take this n and just plug that in as another output. And then back here, we can just connect the n to the n. So now we can press Shift D and just duplicate it, and then press Alt right click and just join these together like that. And remember, to get this right click to work, you have to have Node Wrangler enabled, and it won't work for this less than greater than because we have this n. So actually I'll go in and I'll rename them from n to just greater than and less than. So now everything gets joined up without having to do anything, and you can type in the next letter. So let's say maybe T, and then let's again just press Shift D, plug it in here, and then Alt right click and join them up just by doing this. So that's how easy it is, and you can just change the letter as well. And remember, we have to type in how many letters there are over here. So if I want to type motion, it has to be 6, but if I want to type in maybe motions, it'll have to be 7. So let's just press Shift D and then Shift D again, and you can do this as many times as necessary. But you'll realize that there's still an issue. This I and O have a huge distance between them. If you actually look, they're not symmetric about the x-axis and things like that. That's because the current position of each of these letters is kept at the corner. Let's go back into any one of the nodes, and then let's just change this. We're going to choose a better font. So let's press this, and I'll choose Bank Gothic Bold. I want it to also be filled. So to fill this, I'll press Shift A and search for a fill curves node, plug it in right here, and I'll change this actual alignment from left to center and from top baseline to middle. So that way everything looks better. But right now, if you actually look at it head on, the letters are flat. We don't want this. We want the letters to be perpendicular to what they are currently, so that when they come in front, they can be read. So I'll again take these, shift them a bit, and I'll press Shift A and search for a rotate instances node, plug that in here, and then I'll just rotate them about the x-axis by -90 degrees. But for the pivot point, I'll take this pivot point and plug it in, and I'll switch off local space. So that way we get a nice rolling effect. And if we go back out and use this value over here, we can have them rotate exactly as we want. By changing this integer value, we can get more letters present, and you can clearly see what type of change that makes. So again, this is really up to you as to how many of them you want. I'll make this back down to 7 or 8. And now we can just go ahead with the ending that's after these nodes. So I'll shift this out, and I'll press Shift A and search for an extrude mesh node, plug that in here. I'll change the offset scale to something like 0.1, and I'll also uncheck individual. Then I'll press Shift A and search for a joint geometry, plug that in, and I'll plug in the original instances as well. But again, I have to flip these. So press Shift A, search for a flip faces, and plug that in right here. Next, I need to shade this smooth. So areas like this O have to also be nice and smooth, and we shouldn't be able to see these lines. So I'll press Shift A and search for a set shade smooth node, plug that in here. And for the selection, I'll just go ahead and take this top and plug it in so that this gets a hard edge. But since I want this side to be curved, instead of the top, I have to take side and plug that in. So now you can see we get nice smooth edge over here, but we also get the hard edge over there. That looks perfectly all right. And the last thing that we have to do in the geometry node section is set the material. So I'll press Shift A, search for set material, and plug that in after the set shade smooth. For the material, we'll just choose the default material, and then we'll start off with setting the defaults and the animation. So in our render properties, we'll just switch on screen space reflections, and we'll switch on bloom. Then in our output properties, we'll change the frame rate to whatever you want, maybe 30 frames per second. We'll make it 300 frames long, so that it's a 10-second long animation. Output folder can be wherever you want it to be. File format, we're going to choose FFmpeg video. Encoding, we're going to change the container to MPEG-4, and output quality, we're going to choose perceptually lossless. Then we're going to expand the timeline by a bit, go back to frame 0, and then in this original value node, we can change the value to 0 and then just tap I. And let's say for the first 150 frames, so let's now make this 2-star pi, which makes 1 full rotation, and then we'll tap I. Now if you play this, it's currently set to Bezier, so we have it slow at the beginning, speeds up in the middle, and then it slows down at the end again. If you want to make this even better, we can go ahead and change this from the timeline to the graph editor. Here, I'll just take this right edge handle of this curve that we have, and I'll press S, and I'll just scale it down to 0 so that it starts off really fast and it gradually slows down. But I don't want it to just gradually slow down. I want it to have some sort of overshoot as well. So I'm going to take this and I'm going to just rotate it by a bit so that there's a slight overshoot and it comes back into position. But again, I don't want it to just snap into position when it comes back. So I'll press Shift DX and bring it over to the side, and I'll rotate this back to 0, and I'll just scale it down. Now remember, in case you aren't able to see this itself, you have to make sure that this value node is selected. If any other node is selected, it won't appear. So make sure the value node is selected, and that way it'll come out here. Now again, this I'll just rotate it it a bit and then press Shift DX, bring it over to the side and rotate this down. And that way you'll see you just get a nice overshoot and it comes back. You can always take this right hand side and just scale this one down as well, just so that the overshoots are not too wacky. So that way when you play the animation, you should see the overshoot and then it comes back and then it just wobbles a bit and it comes back into position. So now what I want is some sort of block to block out everything, and on that will also be the reflections. So I'll just press Shift A and search for a mesh plane. I'll rotate it on the x-axis by 90 degrees and I'll press 1 to go into my front view, and I'll just press GX and bring it over to the middle of the word. Then I'll press S to just scale it up, and now when I play the animation, you can see that the back half of these letters are completely hidden. Along with that, I don't want them to come out from exact top over here, so I'll press GY and just bring it front a bit so that I think it's a little bit better. The next thing that we have to do is set up our camera. So I'll select my camera, press Alt G to clear location, Alt R to clear rotation, and then press RX90 to rotate it on the x-axis by 90 degrees. Then I'll press GY to bring it back, and then once it's back, I'll just press 0 on my numpad to go into my camera view, and I'll press GX till I again have the center of the word in the center of my frame. Then I'll press GY to move it back until the entire word fits within my camera. Remember, this word itself, you can actually increase the height of it by using this curved circle in the geometry node section. If you increase the radius, you can see how we increase the height. And then I'll just select my camera and press GY and bring it back a bit more until the word fits. And now in this word, again, you can play around with this integer to increase the number of words that are present and things like that. I'm again just going to keep it at 8 itself. Remember, when you actually use other numbers, there might not be a situation where one is perfectly fitting or is perfectly straight at the camera. For example, when I have 9 or 10, even this one's faced slightly up and this one's faced slightly down, but none of them are facing the camera. In that case, I'll just have to press RX and rotate it a bit until it's perfectly facing the camera like this, and then everything else works the same because the actual animation is done within geometry nodes and the overall object orientation works perfectly fine. So with that out of the way, let's start the actual materials. For that, I'll switch this back to the timeline and I'll switch this to the shader editor. Then with my default material selected, I'll change the name from material to text, and I'll go ahead and give it a very metallic color. And for the roughness, I'll just use a wave texture and I'll change this from X to diagonal and take this color and plug it into the roughness. To actually see the changes, I'll switch over to my viewport shading of render and I'll switch off overlays as well. Now if you look at it, the eye has different scale from the O and things like that. So to fix that, with the node wrangler enabled, I'll select the wave texture and press Ctrl T to get the texture coordinate and mapping node. I'll switch from generated to object and all of them will now have the exact same shading. Now I'll change this from sine to saw, and I think that just looks like a cool texture on these letters. I want to obviously change the color of the letters, so I'll go ahead and maybe give it this sort of a color, and that should be good enough. Next, for the background, I'm going to select it and add in a new material. I'll call it background, and I'll change the base color to maybe a similar color, but I'll just make it a lot darker. And then I'll go to the world properties and change the color all the way to the brightest white. Now for this plane at the back, I'm going to increase the metallic value all the way to 1 so that it's highly reflective, and I'll reduce the roughness to maybe 0.3. I'll just start increasing the saturation until I'm happy with what I have. I'll also select the camera, go to the camera properties, and expand viewport display and increase passport out all the way to 1. So that way I now have this particular animation. The thing about this is that right after it ends, we don't have any motion. So what I want is this plane should come front and hide the rest of the motions except for the one that's there in front. So since we stopped rotating by about frame 225, I'll select the plane on frame 225 and press I location. Then let's say by frame 260, I'll press GY and just move it front until everything is completely hidden except for the first motions. Then I'll tap I location. So that way, this is the animation that we have where it stops moving and then the plane comes front until we have just motions. So that's actually all there is for this animation. Remember, there are other things that you could do in case you didn't want it to stop. You could have made it a perfect loop just by rotating it by 1 full rotation and keeping the interpolation between those two keyframes as linear. That way it would have become a perfect loop, and you could do this not just for letters but maybe different icons, symbols, images, and things like that. So once you're happy with this, you can go ahead and press render animation. I feel like this effect might look really simple once it's created and rendered, but the actual techniques learned within this is extremely powerful because you can use this to make many of your animations much more modular than it is. You can use these for different clients, or you could come up with various other use cases where you use images and things like that as well. If you like this one, I have so many more tutorials just on logos and animations and text animations on my channel, so they're definitely worth checking out. I also make perfectly looping videos as well as sci-fi loops and abstract loops and things like that. I have abstract environments and sci-fi environments as well. If any of those sound interesting, definitely take a look at my channel and watch a few of those videos as well, because I upload a video every single day and I'm sure there's content talent just waiting to be discovered by you. Until the next video comes out tomorrow, thank you so much for watching. Keep creating. Don't forget to stay creative.